Good morning all. I am Anu Sam, Assistant Professor, Alpha College of Engineering. Today I am going to discuss about the basic concepts of electronics. That is, what are the major platform for manufacturing electronic components. So all we know, the electronic components, different electronic components, that is resistors, capacitors, inductors and all. So we know what is the basic material, manufacturing material for these electronic components. So that is we are going to discuss, and why that material is specifically used for making or manufacturing that electronic components. So before that, we are going to see the classification of physical substances, that is physical particles. So there is physical materials can be divided into three. First one is conductors, second one is semiconductor, and third one is insulators. So in the word itself, we can know that conductors means it can conduct electricity. So the conductivity level of conductors is maximum, it is completely conducts the electricity. So in electronic components, based on the electronic components, the manufacturing material is selected on the basis of conductivity. We know we have to pass the current. So material is considered, or material is chosen in terms of conductivity. So in conductors means the conductivity level is very high. So in the second one, semiconductors means the conductivity of the semiconductor is very much lower than the conductors but higher than the insulator. So insulator means the conductivity level is very low, that means the conductivity is zero. For example, if you have example glass, paper and rubber, it does not conduct electricity. So that means the conductivity is zero. So in semiconductor means the conductivity level is higher than the insulator but lower than the conductors. Then the example for conductors is all the metals, that is copper, silver, aluminum, and semiconductor example is silicon and germanium. And this is the major definition of conductors, semiconductors and insulators. Then we can define these conductors or semiconductors and insulators in terms of energy bands. So that is, what do you mean by energy bands? Energy band means a combination of a particular energy levels. So for example, we take the example of semiconductors. Semiconductor, the example is silicon. So we take the example of silicon, and the atomic number of silicon is 14. Atomic number is nothing but the number of electrons or number of protons. So we have the 14 number of electrons, and these 14 number of electrons are occupied in different orbits or different path. So that 14 electrons can occupy in different orbits. In what way they are occupied, in how many electrons are occupied in the first path and how many electrons are occupied in the second path is determined by electronic configuration. So that we can write the electronic configuration of silicon as 2, 8 and 4. That means in the first path or first orbit, it can occupy 2 electrons, and the second path it can occupy 8 electrons, and the last one it can occupy 4 electrons. But we can say that the last path can accommodate a maximum of 8 electrons, but in this case we have only 4 electrons. So these electrons are occupied in different orbits or path. That is, the first path it is occupied by 2 electrons, and the second path is 8, and the last path is 4 electrons. But it can accommodate another 4 electrons. There is a chance for accommodating 4 more electrons, but you have only 4 electrons. So we can see that the last path is partially vacant. That means the electrons can move freely around the path. But compared to the second path, it is tightly filled with the 8 electrons. So it is all the electrons are restricted to move around the path. Compared to the second path, the third path, the electrons can freely move along the path because you have only 4 electrons. So that electrons are called as valence electrons. And this orbit is called as valence shell. So the electrons present in the valence shell is called as valence electrons. So you have in silicon, you have 4 valence electrons. So similarly, you all know these electrons are moving, right? So electrons are moving means it has some velocity. So the velocity is related to energy. So for a moving object you have kinetic energy. So that kinetic energy is related with half mv square. That is, it is related to the velocity. If you are moving with, these electrons are moving with some velocity and it possesses some kinetic energy. But all the electrons does not have equal amount of energy. All the electrons have different levels of energy. However, it have different levels of energy. That is, electrons in each path. That means electrons, we have 2 electrons at the first path. So that 2 electrons have somewhat equal energy levels compared to the second path. And you have second path, you have 8 electrons, and 8 electrons have slightly differing energy levels. So you are combining the slightly equal energy levels into a band. So that is called as the first energy levels, that is the energy level of the 2 electrons is somewhat slightly equal. That is combined together to form the first band. First band means the energy level of the first shell or first path. And the second one is, second band is consisting of the energy levels of the second path or second orbit. And the third one is, it's the energy consisting of the third shell, or there is a third band, or it is otherwise called as valence band, because these electrons are the last shell electrons are called as valence electrons. So that the energy of that valence electrons is called as valence band. So you have, for silicon you have 3 bands, first band, second band and the third band, or otherwise it is called as valence band. So the last 2, that is the first 2 bands are, the first band and the second band are completely filled. You know, in this electronic configuration it is completely filled 2 and 8. So the first band and the second band are completely filled. What about the third band? The third band is partially filled because it only have 4 electrons. So the energy level is partially filled in valence band. So you have 3 bands, you have to conduct electricity. You want conductivity. So conductivity means you have to pass the current. So in order to flow the current means you have to, that is due to the movement of electrons. You have 4 electrons here. The first band you have 2 electrons, that is completely filled. That is tightly held. There is no chance of moving from one band to another. Here also in second band also you have 8 electrons, that is also completely filled. There is no chance for moving from these electrons to first band or third band. But here in third band you have only 4 electrons, there is enough space to move from one band to another band. So these valence electrons in the valence band can move to another level because it can't move to the second or first level because it is already filled. So it can only move to another band, that is a vacant energy band, that is called as conduction band. So these electrons are moved to the conduction band. So that is called as, those electrons are called as free electrons because that electrons are free to move. So these free electrons are responsible for the flow of current, so that we get the conductivity. Next one is, we already defined conductors, semiconductors and insulators based on their properties. Next is, we can define that conductors, semiconductor and insulators based on their energy band diagram. So energy band diagram means you have valence band and conduction band. So based on that we can define conductor, semiconductor and insulator. So here we can see that it is partially filled, valence band is partially filled and conduction band is vacant. So there is some energy difference between conduction band and valence band. So that energy difference is called as forbidden energy band or forbidden energy gap or EG. So that is the energy gap between valence band and conduction band because the valence band is partially filled and the conduction band is empty. So there is an energy difference. That energy difference is called as forbidden energy gap. So based on the value of this one energy gap, you can define conductor, semiconductor and insulator. So in conductors means you have high level of conductivity. So as I said earlier, due to the movement of free electrons, you can have conductivity. So in conductors you have maximum conduction. So you have a free movement of electrons from valence band to conduction band. So you have to move electrons from valence band to conduction band means in between this valence band and conduction band there should be no barrier. That is, the electrons can freely move from valence band to conduction band. That means the energy gap should be 0, so that the electrons from the valence band can easily move to the conduction band. So there is a conduction of current or conduction of electrons. Next one is semiconductors. So in semiconductor means you have partial conductivity. So that is, conductivity level is lower than conductors and higher than insulators. So in that case you have some energy gap between valence band and valence band and conduction band, but it is lower than the insulator. So in insulator you have no conductivity, the conductivity is 0. That means conductivity 0 means you cannot have the free movement of electrons from valence band to conduction band. If you can't move the electrons from valence band to conduction band means the gap between the conduction and valence band is very high. So there is no movement from electrons from valence band to conduction band because there is a barrier here. That is the forbidden energy gap. So you have in insulator the energy gap is very high, that is 5 electron volt or more, but in conductors you have energy gap but it is less than the insulators, that is for example 0.72 and or 1.12 electron volt. So that is the definition of conductors, semiconductors and insulators based on the energy band diagram. Have you all understand? The next one is we can move to semiconductors because conductors can conduct very that is completely. When temperature, that is we can compare it with the temperature. So above the room temperature, if we increase the temperature, the conductivity of the conductors is very much high. So depending upon the temperature, if temperature we increase, the conductivity also increases in conductors. So in that case, if the temperature is very much high means the flow of current is very high. So that should, if there is a huge amount of current flowing through a device means it will damage the device. So we can't use conductors for the manufacture of electronic devices because we can't predict the temperature rate. So if the temperature rate increases, the conductivity of current flow increases, it will damage the device. So second case, semiconductors. So in semiconductors it will partially conduct, and if it has a negative temperature coefficient. Negative temperature coefficient means it is inversely proportional to temperature. That is, if the temperature increases, the conductivity decreases. If there is a chance for increasing the temperature means the conductivity decreases. So there is no risk for damaging the device. For that reason, we are using semiconductors for the manufacture of electronic equipment or electronic devices, components. And one more property for semiconductor is we can improve the conductivity. So as I said earlier, the semiconductors have partial conductivity. So we can increase the conductivity of the semiconductor by adding some elements or some impurities to the original semiconductor. Original semiconductor is silicon and germanium. So we can add some more elements along with silicon or germanium. We can increase the conductivity of semiconductors. So that process is called as doping. So the process of adding some impurities to the original semiconductor material in order to increase the conductivity is called as doping. So semiconductor is a material we are used for manufacturing electronic components or equipments. So we can we have to know more about semiconductors. So semiconductors can again divided into two, that is intrinsic semiconductor and extrinsic semiconductor. So intrinsic semiconductor means there is no other materials, that is the semiconductor in its pure form. That means no other impurities are added, that is semiconductor in its pure form, that is silicon or germanium, is called as intrinsic semiconductor. Next is extrinsic semiconductor. So extrinsic means in order to increase the conductivity you have to add some more elements. So that is called as extrinsic semiconductor. Extrinsic means some external materials or impurities are added. So that should be again divided into two, that is N-type semiconductor and P-type semiconductor. So N-type semiconductor means you are adding along with silicon or germanium with a pentavalent impurity or pentavalent impurity, or otherwise it is an element, pentavalent element. And P-type, you are adding silicon with a trivalent impurity. Pentavalent is nothing but pentavalent means you have a valence electron of 5. An element having a valence electron of 5, and here you have adding a trivalent. Trivalent is nothing but an element having valence electron 3. So these are the major divisions of semiconductors.